So in this problem, we got a car which is going 8 meters per second, and it applies the brakes and comes to a rest at 0 meters per second. They also tell us up in the problem that the mass of the car is 1,000 kilograms and that the force of friction exerted on the car to stop it's 8,000 newtons. They want to know how much kinetic energy it had in the beginning, how much work was done on it, and then what was the distance it took to stop. So let's start to solve those. The kinetic energy one here is pretty straightforward because kinetic energy is equal to 1/2 times mass times velocity squared. So we can straight up plug those in. We know the mass is 8,000. We know the velocity is 8 and have to square it. So 8 squared is 64 times 1,000, 64,000. Half of that is 32,000. So 32, I'll write that over here where the blank was, 32,000 joules of kinetic energy in the beginning. Up here, this is easy. If we have no velocity, then we have no kinetic energy. So our kinetic energy is 0 joules there. So they want the work, and you're like, but I don't know the distance. I can't calculate the work. But remember, work is also equal to the change in kinetic energy. And so the kinetic change of anything is final minus initial. So, but also just think about it. If we went from 32,000 to 0, then we took away 32,000 joules of energy. And that means our work is also negative 32,000, a drop of 32,000 joules. But you could plug this in here. Final 0 minus initial, which was 32,000, you'll get negative 32,000. So then the last part there is the distance that it moved. So not only is work equal to the change in kinetic energy, but now we can finally say work is equal to force times distance times the cosine of the angle between those two. So we know these three things, we can find the fourth one. So work, we already know, is negative 32,000. The force they gave us, let me change that to a parentheses, is 8,000 newtons. We're looking for the distance, and the angle between the two is 180 degrees. How do we know that? Well, it would have moved this way. That's the distance, but the force of friction would have been back this way. So there's 180 degrees between them. That makes that cosine of 180 degrees is just -1, and that will cancel that negative. So we wind up with 32,000 is equal to 8,000, sorry, I keep writing F, times a distance. So if we solve for that distance there, we get 32,000 divided by 8,000, then that distance is just 4 meters.